Paid the price and now I know I'll be alone and you'll be gone. What's the point in all these games if all they do is drive us insane? Thought we'd always stay the same. Cross me out like Tic Tac Toe today.
I'm going to show you what I did. I'm going to show you what I did during my lab session, which is part of my electrical engineering course. But let me explain something first. This semester, which is year 3 semester 2 of my degree life, things have gotten more interesting as I'm required to do more hands-on than just learning on paper. Within a span of 3 weeks, we were assigned a project to solve a specific problem, and this time, we are going to design an elevator system.
See, we can fall apart tomorrow, but tonight, let's see.
With the limited time that we have, aside from attending classes and completing homeworks, it has become a challenge for me and my team member to explore and learn everything from scratch while completing the project. In modern elevators, the device that is used to control elevators logic is called Programmable Logic Device (PLC). The PLC is connected to various sensors and devices in the elevator such as the door selecting buttons, door sensors, as well as the motor controller. It receives input from this device and uses that information to control the elevator movement, including the opening and closing of door and stopping at the desired level. To complete our project successfully, my team and I needed to conduct extensive research on how to program PLC by constructing ladder diagrams, which is an entirely new concept for us. After getting used to how the software works and getting familiarized with the basics of ladder logics, we came to realize that it is certainly difficult and messy to design all the features of an elevator system all at one time. So instead, we focus on designing the elevators moving up and down system, which is the most crucial one. Since there are 3 floors available for the elevator models, therefore, our team considered all possible cases for the elevators to move up and down. The first step is to draw a flowchart to determine the inputs and outputs that are needed for our system. Once we have those, we can start constructing ladder diagram to program the PLC. We also make sure that the inputs and outputs addresses on the PLC matches those in our program. And after going through several trial and error, here's the result. As someone who has liked manager stuff since I was young, I absolutely enjoy seeing such big or familiar things we use in our daily lives being scaled down to such a small version. You just can't resist touching them, testing the functions one by one. Honestly, it was, I can't say the best, but the most interesting lab experience I've ever had so far. So guys, this is my friend Mujin,
Hey guys, hope you're doing well.
and he will show you what he is doing in this lab. Basically, he is doing factory automation trainer, right?
Yeah, that's right.
So something about factory, and he will describe about it. So yeah,
So
let's
hopefully you guys find this useful and beneficial.
yes. Okay, let's start.
Hey guys, so today we're going to be explaining the conveyor belt action in a factory automation system. And the system basically works with these cylinders, which basically separates the defective cylinders from the non-defective cylinders. Okay, as you guys can see here. So basically, what's going to happen is that this is going to help us basically separate them by placing them into these boxes right here. So this is like the non-defective cylinder, and this is the defective cylinder. Okay. So first of all, to begin the process, we're going to be having a piston here. This piston works on supplying the cylinders to the drilling component. Okay. And then after the components are drilled here, they're going to be pushed by the piston here in order to process the cylinder. Okay. So the cylinder is gonna pass through like a group of sensors. Okay. This sensor here Okay, it's a what do you call it? Defective cylinder. Okay, so for this cylinder, it's considered as non-defective. So when it passes through the conveyor belt, it passes through the cylinder here. Okay, and if you guys can see here that S2 is off, this is the defective cylinder. Now it's off. So when we put the cylinder here, okay, it's off. So this is non-defective. So when we put the metal, okay, as you guys can see here, it's on, which indicates that this is defective. And then it's gonna instruct the plunger to push the defective cylinder onto here in case it's defective. If it's non-defective, it's gonna be here, and then it's gonna keep on going. It's not gonna push basically because it's gonna be off, as I said. So to begin the process, we're gonna be placing both of those cylinders inside the tube. Okay. So we're gonna be putting them inside the tube. Okay. Okay. So as you guys can see here, S1 is the part sensor. S1 is on, which basically detects whether there are cylinders inside the tube, which is like here. Okay. So after we're done with placing our cylinders, which are required for processing, we're gonna close the tube. Okay. And we're gonna start the process. So to show you guys a demonstration, we're gonna start the process. The plunger pushes the cylinders. It's gonna drill. After it's drilling, it's done. It's gonna pass through the sensor. Detected defective. So defective is pushed out. Okay. Then for the non-defective cylinder, it's gonna be drilled for 3 seconds. After it's done with drilling, it's gonna be pushed onto the conveyor belt. And then it's non-defective. The sensor won't light up, so this won't push the cylinder to the defective box, rather the non-defective box. So this is done on a large scale in factories, and this is only a small scale to show you guys the capabilities of conveyor machines. So these machines are capable of like many other uses, and this is only a small scale use of it basically. So that's all, and I hope you guys had a good viewing experience. And thanks for my friend for.
I don't wanna say goodbye.
Anyway, I hope that this video gives you an insight about control engineering. If you are a student who want to determine the future course to enroll in university, then control engineering might be a choice for you. Maybe you can take the same path like I did, that is by choosing electrical engineering as your degree, and then selecting control engineering related subject as your elective during your 3rd or 4th year. As much as I enjoy filming this video, I hope that you guys could took something out from it. A big thanks if you are still watching here. Hopefully, I'll see you soon in the next video. Bye.
I'm barely coping. I need to pick me up to save myself from all the hell that you caused. I'll cry for help, but I ain't getting no response. I'm all